Welcome back. In this lecture, I'm going to show you that how you can configure your high waters application with the Firebase backend as a service. The first thing you need to do is you need to make sure that you are signed in with your Google account. I'm already signed in and I'm on Google, so I'm just going to search for Firebase Console. And you will see that you can go to the Firebase console by simply going to console.firebase.google.com. Let's go ahead and click on the first link, which will take me to the Firebase console. And you will see this welcome page, and also a page which will which will allow you to add a new project, new Firebase project. Now, when you are adding Firebase project, you can add 8 to 10 free projects, and then after that you will have to pay for those projects. But 8 to 10 projects are, they're too much, so you should be good. So let's go ahead and create or add the new project. And you'll see that it's going to ask you for the name of the project that you want to create. That's just the name of the project for the Firebase. We're just going to call our project High Waters. And let's go ahead and say Create Project. Now you can see on the Firebase console, it is creating and setting up a project for you from scratch. And it's quickly going to, create the project. And now you can say that, saying that your new project is ready. Let's go ahead and click on the Continue button. And now you are taken to this nice screen which asks you that, okay, are you building an iOS application? Or are you building an Android or a web application? Firebase database and Firebase services will work with iOS, Android, as well as web. So once you have your data stored in a Firebase service or a Firebase database, you can access the same data using an iOS application, Android application, and also a web application. We're more interested in iOS, so I'm going to click on the first one. But the first thing it's going to ask you is, well, what is the bundle ID of your iOS application? Let's go ahead and check out the bundle ID. I'm going to open up Xcode, and this is my High Waters application. I'm going to click on the project, which is this blue icon over here, and you can see that the bundle identifier that I have, which uniquely identifies my application, is com.azamsharp.highwaters. I'm going to select that and go back to the page and enter that. Make sure it is exactly that. Exactly. All right. Let's go ahead and register the app. Now, once you register the app, you can see that now the Firebase is kind of like guiding you through a wizard that's what you need to do next. So basically Firebase is telling you that, hey, go ahead and download the Google service-info.plist file. And I can download this file by simply clicking on it. So let's go ahead and click on it. And it will have that downloaded. Now I do have multiple files over there, so don't worry, I'm going to clean it up and download it again for you. There we go. I've downloaded it again. And now it will be called Google Service Info Plist. Now let's go ahead and add that file. I'm just going to drag that file right into my project. You can see I'm simply dragging it. And I'm going to finish basically adding the file to the project. You can see that the new info.plist file is now added to my project. Let's go back to the wizard again. And let's see what it's saying more if we continue on next. Now it's telling us that we need to initialize a pod, basically a CocoaPods, and then we need to add the pod which is Firebase Core. Now, if you are not familiar with CocoaPods, you can go to the CocoaPods website and install CocoaPods. CocoaPods are basically a dependency manager, so they will allow you to download different frameworks and libraries easily and integrate it with your iOS application. So make sure that you have CocoaPods installed If you don't have CocoaPods installed, then you can go to the CocoaPods website and install the CocoaPods gem. Once you have that gem, then you can run the pod init command. All right. So next, we are going to go into the folder of where our application is. And from there, we are going to run the pod init command. When doing anything related to CocoaPods, I usually try to close Xcode and then proceed with the CocoaPods. So let's go ahead and do that. Just going to minimize this window. And you can see that this is my Xcode for the High Waters application. I'm just going to close that for time being. And you'll see that I'm already inside the folder. So you should be able to see your High Waters folder, and you should be able to see your Xcode project file. Now inside this folder, I'm going to say pod init. Basically, I'm initializing a CocoaPods. Now if I view the directory, you'll see that magically there's one more file added. And that file is called pod file. This is where you will specify that what other frameworks and dependencies you need to integrate with your High Waters application. Let's go ahead and open up this pod file. And you can use any editor to open that file. And you can see that this file is in a different format. This is basically a file that will be used for CocoaPods to download different dependencies. Now, if we go over here into our instructions from the console.firebase.google.com, you'll see that inside the pod file, we need to add this particular pod, which is the core framework for the Firebase. Let's go ahead and copy that and go back to our CocoaPods, and I'm just going to paste it right here. You can see I have pasted right here. Save it. Make sure to save it. Let's go ahead and save it also. Done. Now we can close this file out. And now from the same place where you were, just go ahead and say pod install. Now if I run the pod install, CocoaPods is going to look at the pod file, and it's going to find all the different pods, which in this case is only Firebase core pod or the Firebase pod, and it's going to go ahead and install it. Let's go ahead and run this, and you will see that now CocoaPods have downloaded these dependencies and installed it for our application. Now, also you will notice that CocoaPods is telling you that please close any current Xcode sessions, and from now onwards you will be using highwaters.workspace file instead of the highwaters.xcode file. Now, where is this Xcode workspace file? You never really created it, right? Well, go ahead and say ls, meaning view the directory. And you will see that CocoaPods has actually created a workspace file for you. So let's go ahead and open this particular folder by saying open period or open dot. Right click on the workspace file, open with Xcode 9.2. And you will see that it will look exactly kind of like the project file, but the main difference is that the CocoaPods dependency has also been added. And if you look at the pods, you will feel, or you will see that all the different Firebase pods that are necessary for the Firebase to work have been added. And the great thing is that you can go into your view controller and you can now simply say import Firebase. See how easy it is? By using CocoaPods, you can easily go ahead and import Firebase. Just like that. Let's go back to our instructions and let's see what it's saying. We have already run pod install, so let's go ahead and continue. Next, it is saying that you need to configure the Firebase project or the Firebase library or the Firebase app. And this can be done inside the app delegate. There is a code for Swift and also Objective-C if you're using Objective-C. We're using Swift, so I'm just going to click on Swift. So now I need to find out the app.delegate file, and inside the did finish launching with options, I need to fire this particular function, which is going to configure my app as an Firebase application. So let's go ahead and do that. Here is my app delegate file. I'm going to import Firebase. So let's go ahead and do that. And inside my did finish launching with options, I'm simply going to call Firebase app.configure. And that's all you need to do to configure your Firebase application. Now, in the next lecture, I'm going to show you that how you can create different nodes, and we can delete nodes and add nodes and view all nodes and get all nodes. So a lot of different stuff, cool stuff, will be coming in the next few lectures. Thank you so much. Now that we have created our Firebase project on the Firebase console and also enabled the Firebase in our application by using CocoaPods, we are now ready to store the location information of the flooded region, basically the latitude and the longitude, onto the Firebase backend as a service database. Before we do that, we do need to enable a couple of different things on the console to get it to work correctly. So let's go ahead to the console first. Okay. After configuring our Firebase project, I can simply go ahead and finish it up. And you will see that it kind of creates an empty project for us. Now we can go ahead and say develop, click on the develop option on the left. And you will see that there is authentication, database, storage, hosting, and functions. We are more interested in database because we want to save some data onto the Firebase service. So let's go ahead and click on the database. We are more interested in a real-time database, so let's go ahead and get started with that. And you will see that it creates the root node, which is the high waters, which is the name of our project, but it's already created a root node for us. One of the things that you have to do, especially in the development environment, is to enable the read and the write for your application. If you don't do that, you will not be able to read or write to the Firebase database. To enable the read and write access, simply go ahead and click on the rules, and you will see that the read access as well as the write access will not really work unless you are authenticated successfully. Now that's completely fine for your apps in production, but when you're starting out, you do want to check that if you can successfully save the data into the database or not. So for now, I'm just going to call it, or just going to change it to true, meaning that yes, people are allowed to read as well as write to the database without being authenticated. Now once again, if your app does need authentication, then do not change these settings, or you can change it and then later change it back to requiring authentication based on your app. But since we're just getting started, I'm just going to allow the reader, the developer, to read as well as the write to the Firebase database. Go ahead and click on the publish. If you don't click on publish, the settings, the changes that you have done to the settings, it's not going to take an effect. And now you can also see that your security rules are defined as public. Anyone can read or write to your database. If this is not what you need, then you need to revert back to some other setting. But right now, it's okay. We're just starting out. We just want everyone to communicate with the Firebase database to allow us to, or to tell us that this particular area has been flooded or not. I'm just going to dismiss that for now and go back to our code. Now let's go back to our view controller, because this is where all the stuff actually happens. And right now you can see that whenever we click on the add a new flood button press event, we're simply adding it to the map view annotation. This means it definitely is visible to the map, but once we run the application again, everything is gone because it's not really persisted anywhere. It's simply persisted in memory, and obviously when you launch your application again, well, it's brand new and memory is discarded and refreshed and everything is kicked out, meaning you don't really have any annotation. So we need to save that part of it. We need to save the location of the flooded regions so other people can also see that this particular area is flooded. We shouldn't even be near that area. So how can we do that? We will start by creating some sort of a class that is going to represent a flood object. So we're going to start with adding a new file, and we're going to call that file flood. Now obviously you can call it anything you like, but I think flood is a good name because it represents that this file is about a flood. I'm going to create a structure of flood. The flood is going to have two different things: a latitude, which will be of type double, and also longitude, which will be of type double. Now, you don't really need to create a flood object. You can simply go ahead and add some things in the dictionary with key value pairs and then save that information to Firebase. But it's a good idea to represent your domain objects in the form of classes or structures, depending on that. So now our flood object has been created. Let's go back to our view controller. On line number 58, we get the location from the location manager. Now this is the current location of the user. And this is a great point for us to get the location, get the coordinate for the latitude and longitude, create a flood object, and then somehow save that object onto the Firebase. So let's go ahead and do that. If I say location.coordinate, it's going to return me the coordinates for that particular location. And that location is my location where I am. So let's go ahead and say coordinate and move it into a coordinate variable. Now I can go ahead and create a flood object. So flood equals to flood, and I have to pass in the latitude and the longitude. The latitude and the longitude in this case represents the location where I am notifying that, okay, this is a flooded region, and the latitude and the longitude are these values. Which these values? Well, the values that I'm currently standing. So coordinate.latitude and coordinate.longitude. That would at least create an object of type flood, which will have a latitude and the longitude. Now somehow we need to get this value and save it on to the Firebase. Now if you remember correctly, Firebase saves all the information in terms of a JSON tree. Now if I go and look at the tree right now, you can see that if I go and check out the data, the tree only has one root element, which is the name of the project with the ID associated with it, right? Somehow we need to get access to the root object, the root node. Once we have access to the root node, then we can attach different nodes to the root node, forming a tree-like structure. But how do we get access to this root node? Because if we don't get access to this, we can't really create our tree without the root. So let's see how we can do that. The first thing I'm going to do is I'm going to create a property, private var root reference, which will be of type database reference. But now you will see that there is no such thing as database reference. And this is where we will have to go back to the pods again and make sure that we install the dependency on a package that will allow us to save data to the Firebase database. So let's go back to the console. We're going to go back to the terminal, ls, and go ahead and open the pod file. In the pod file, you already see that you have a dependency on the Firebase core. But if you do want to do something with the Firebase database, which we do, we have to add another dependency on Firebase/database. That's just another pod that deals with the database part of the Firebase. Go ahead and save it. I have already saved it. Once you have saved it, go ahead and run pod install again. Pod install is going to look at your pod file and it's going to install all the dependencies again. If those dependencies are already installed, then it's going to move to the next one and install the next dependency. And now it's actually installed. Now let's go ahead and see if it knows anything about the database reference. It's a good idea to also build your application first so that you know that everything is in a good condition. And let's go ahead and build it again. All right, let's go ahead and build it. Oh, we actually are in a different folder. All right, let me actually fix that. Hold on a second. Okay, my mistake. I was in a completely separate folder for my application. So let's go ahead and do that again. All right, I'm going to open the pod file and open pod file. Yep, I was in a completely separate file. So let's go ahead and do it again. We're going to add a pod, and the name of the pod to interact with the database is Firebase database. Go ahead and save it, close it, and run pod install. Now I am in the correct folder, and you can see my project actually refresh on the left-hand side. And now let's go ahead and build it so that we are sure that nothing got messed up. And once it is done building, we can go ahead and refer to our new Firebase database. So root ref, and you can see that now you can actually refer to the database reference. Once you have the database reference, the next step, or the root reference, the next step would be to make sure that it is pointing to the root. So this can be done inside the view.load. I'm just going to do it right over here. I can say root reference equals to database dot root or reference, just reference. Okay. So this is going to get us the access to the root reference. All right. And using this root reference, we can create different nodes on Firebase. Let's go ahead and see how we can actually do that. Okay, so now that we have access to the root reference, if we go back to our add flood annotation pressed, over here, we need to add a child to that root reference. So if you remember correctly, this is our root reference right over here. We need to add a new child to this root, and we can say flooded areas or flooded regions, whatever you want to call it. It's up to you. So that is exactly what we want to do. So I'm going to say over here, let and flooded regions ref equals to, using the root reference, we are going to create a child, and the name of the child will be flooded-regions. You can obviously name this child anything that you like. Once we have the child flooded regions, we can add a new child which will represent this particular flood. All right, so let's go ahead and do that. Flooded regions ref dot child. And what do you want to call the node? Well, I would like to call it, let's say, flood, okay, or flood 1, whatever you want to call it. And then I can say this is flood region ref, or just call it flood ref. All right, so basically what's going on is that inside the root, which is this one, we're going to create a new leaf over here, or a new node, which will be flooded regions. And inside the flooded regions, we're going to create another node which will be called flood 1, which we are doing over here. Now the flood 1 will represent the actual flood, and we already have the flood object. So let's go ahead and do that. Flood ref dot set value and flood. This compiles okay, but if you run this right now, it's not going to work because Firebase has no idea what to do with your flood object. Firebase is okay to work with strings, integer, floats, double, arrays, and dictionaries, but it has no idea how to manipulate your custom structure or your custom classes. So a good idea at this point is to somehow convert our flood object or a structure into a dictionary. And we can easily do that. So let's go back to our code, and this is our flood object. I'm just going to add a helper function, which will be toDictionary. It is going to return us a dictionary, which has a string as a key, and the value can be anything. We are not sure what the value is. That's why we're going to put any. Now we're going to return you a dictionary where the key is latitude, the value is the actual value stored in the latitude property, the key, another one, is called longitude, and the value is stored the longitude. Let's go ahead and build it. Works fine. Now let's go back to our view controller, and instead of sending the flood object, we're going to send in the dictionary, because once we send the dictionary, it will know how to convert it and how to persist it on the Firebase. With all of these changes in place, let's go ahead and run our application and see if it persists the annotation on the Firebase database. All right, so let's go ahead and run our application, and we're going to see that if we added annotation, is that annotation going all the way to the Firebase or not? Now on the left hand side you can see that this is my simulator, and on the right hand side you can see that this is the Firebase Console. The great thing about Firebase is that as soon as you add something from your web application or Android application or your iOS application, it will immediately be reflected over here, so you don't really have to refresh anything. Of course, if it doesn't add it over here, that means that something has actually went wrong. Let's go ahead and do that. Let's go ahead and press the button over here, and you can see that as soon as I click the button, it has added a flooded regions node right inside the root node. That's what we said, right? And inside this flooded region, I should be able to see a new node called flood 1. Oh, yes, here it is, flood 1. And inside the flood 1, I should be able to see the latitude and the longitude. Latitude and the longitude. Beautiful, right? Now, obviously, if I click this again, it's going to override flood 1, because this is always, we are creating a key or node called flood 1. So this is going to get overridden again and again and again and again, right? But we can see that it has actually saved the flood information, but we still have a problem because I can't really notify some other flooded areas Because if I do, I'm using the same exact node key, flood1, which gets overwritten, so the latitude and longitude gets changed if it is changed. Otherwise, well, most of the time it's not changed because I'm not really moving at that point. But it's great to see that now your application is connected with Firebase database and it is storing on the Firebase server. In the next lecture, we're going to drill more into different ways of storing into the Firebase database and also how to retrieve the values once it has been stored. In the last lecture, we were able to integrate our application from the Firebase database, and we were able to save the flooded region onto the Firebase backend as a service database. One of the issues that we faced was when we were creating a node representing a flooded region, we were using the flood title or the name as flood1. What this does is that any time it's creating a node, it will always call it flood1, meaning that it will always overwrite the existing value of flood1. So how can we solve this particular problem? Well, we can solve it in many different ways. Let's go ahead and find a solution. The first thing we're going to do is maybe add an integer that is going to increment anytime we want to add a new flooded region. So first time it will be flood1, then flood2, then flood3, and so on. So maybe we'll call it flood counter. And we will initialize this value with, let's say, 1. All right. Now I will go back over here, and whenever we're trying to insert or create a new child, we are going to say flood and insert the value of self.floodCounter. Okay. Let's go ahead and first of all delete our flood1 because we want to kind of like start from the beginning. So I'm just going to remove that. And you can see that it immediately removes it from the Firebase database. Now let's go ahead and also obviously increment the flood counter. So when it is added, we're going to say self.floodCounter is plus equals to 1. Let's go ahead and run this. And if we add multiple flood items, it should create us multiple nodes representing different floods. I'm going to press this button, and you can see that now the flood1 is created. I'm going to press it again, and now flood2 is created. Obviously, it has the same latitude and longitude because we're not really moving. We can actually even fix that issue. So let's go ahead and see how we can actually move. On the simulator, click on the debug location and select from these pre-simulated routes. You can do a city run, a freeway drive, or a city bicycle ride. I'm just going to say a freeway drive. Now you can see the simulator has been updated and our object is no longer a stationary object. It is simulating a freeway drive. So you're basically driving in a car. And now I'm going to say that, okay, this area is flooded, so don't come over here. You can see that it adds the annotation and it also adds the flood3. And you can see that the flood3 latitude and longitudes are very different from what was in flood2 and flood1. This is all okay and it's working completely fine. Flood1, flood2, flood3. But we can, when we start the application again, the counter will reset again to 1. How do we fix that problem? Well, it turns out that in Firebase, this is such a common operation that there is already a very easy method of solving it. Let's go ahead and see how we can do that. Instead of using the flood counter and creating our own variables, we can actually use something called the child auto ID. So instead of saying flooded region.flood and then passing in the name of the child, we can just tell Firebase to create a child and name it anything. just automatic ID. You can see that child by auto ID is available to you. And that's pretty much it. Once you do that, you don't really need any flood counters. So let's go ahead and remove these flood counters. Also, we're going to go to our Firebase console and remove all the other flooded items. So I'm just going to delete it and we'll restart and begin from when there were no flooded items. Let's go ahead and run this application now. And now you will see that whenever I will add a new flooded item, it's going to randomly assign some sort of a code to that particular node that gets added. You can see that we are simulating a freeware drive. I'm going to say add a flood. And you can see that it actually adds a flooded item and give it some sort of a random ID. So I don't have to manage the flood 1, flood 2, or flood counter anymore. It's all automatically managed for me. You can see that the driver is going really fast. I'm just going to say I found the flood at this region also, don't come over here. And I found the flood on this region, so don't come over here either. And you can see that anytime I press, you can see that it's creating new IDs and with new latitude and longitude. All of these IDs are obviously different. They look a little bit same, but they are all different, as you can see. And in this way, we have created our application and integrated with Firebase and also created a unique IDs, allowing us to save multiple items into the Firebase which are represented the flooding areas or the flooded regions. Now, in the next lectures, we're going to learn how we can pull up the data from the Firebase and display that information onto our app. Because if you run the app right now, let me start it again, you will see that although we have these items added, we have these locations added, we don't really see anything on our screen. There are no annotations, nothing. We need to put these annotations onto our map so that everyone can benefit and everyone will be aware of the flooded regions. And that is what we're going to do in the next lectures. Hello and welcome back. In the last lecture, we learned how we can save the flooded area, the flooded region, into our Firebase database. And in this lecture, we're going to learn how we can retrieve those saved, persisted, flooded regions from the Firebase database and display it on our map control. So let's go ahead and do that. The first thing I'm going to do is I'm going to go ahead and create a separate method which is called Populate flooded regions. Now you can obviously call it anything that you like. I'm just going to call it Populate flooded regions, private function populate flooded regions. There we go. Okay. Now inside the method, inside the function populate flooded regions, I will have to somehow fetch all the flooded regions and then display it onto my map view control. So the first thing I'm going to do is going to use the root reference and point to the node on which I want to create an observation. So if we go ahead and look at our data that is being saved, you can see that right now we have a root node over here, which is the high water C8429. And we have a node inside the root node, which is flooded regions. Now in Firebase, you can watch a certain node that whenever anything happens to that node, which means that whenever some child node gets added, whenever child node gets renamed, deleted, updated, created, you will get a notification of basically all the child elements, which has basically all the child elements, not the one that have changed, but all the child elements. So first of all, we're going to get that. We're going to get a reference to the flooded areas or the flooded regions node. And we are calling it flooded regions over here, but obviously you can call it anything you like. So we're going to start with self flooded regions ref equals to self dot root ref dot child with a path, and in this case we are talking about flooded regions. So we're just getting a reference to the flooded regions node, this particular node, flooded regions. All right. Once we have the reference to the flooded regions node, we can add an observation on it. So we will most probably say flooded regions ref dot observe. That's one of the functions of the Firebase framework. And observe on what? Now there are many different things that you can observe on. I'm just going to use the default one, which is the value, which means that anytime anything changes in the flooded regions, meaning adding a new node, deleting a node, renaming a node, updating a node, we will get that notification. And we will also get that notification at the start, like when the application actually starts. So this is the event we want to observe, and it's going to give us a snapshot. Now let me actually go ahead and use the trailing closure. That's much easier to understand, I think. So let's go ahead and do this and call it snapshot in. A snapshot is simply the snapshot, the picture. If you take a picture of something happened, so it's going to return the nodes, that particular node, when any value of any of the child nodes changes, or deleting, or updating, or renaming, or anything you're doing. So anything happens to the child node, this particular snapshot with the flooded regions is going to be given to us. All right. Now, what does the snapshot contains? If you look at the flooded regions, the snapshot will actually contains a list of these nodes. Not the ones that have been changed. We are getting like everything. So we will have a list of these particular 3 nodes, because there are 3 right now. And these 3 nodes are actually dictionaries. So let's go ahead and do that. Let flood dictionaries, and you can call it anything you like, snapshot dot value, and we're going to cast that value as a dictionary of string key and any value. If it doesn't exist, then go ahead and use an empty dictionary. All right. Now, once we have the dictionary, which is this portion, 3 of them right now, we can go over and iterate over the dictionary. So let's go ahead and do that. For key and value, we don't really need value at this point, value in flood dictionaries. All right. And now I can check over here if let flood dictionary equals to flood dictionary dictionaries. So where is our flood dictionaries, which is this one? Flood dictionaries of key can be converted into an object of any. Let's go ahead and first build this. So now we are at the point that we are iterating towards these values, through these values, and now we will be able to access the latitude and the longitude. So flood dictionary will contain the latitude and longitude. So I can say something like if let latitude equals to flood dictionary, or flood, the small one, the flood dictionary over here, and the key is latitude. This is a key that is coming from the Firebase, and we're going to again convert it to double because right now it will be any. And another one is longitude, which is flood dictionary of longitude as double. Then we'll do something over here. All right. Now, once you get these latitude and longitude, you can also go ahead and create your flood object, which actually takes in a latitude and longitude. All right. So if I go ahead and look at my flood, the structure that we created, we can actually extend the flood structure. It's just a good practice. You don't really have to do that, but I think it's a really good practice that you do this. We're going to create an initializer, all right, and which is going to take in a dictionary. So it will be string and any. And now we can use the guard statement. So let guard latitude equals to dictionary latitude. And you'll see that how this actually simplifies the code in a moment. All right. So we'll get the latitude and we will also get the longitude in this way. Longitude, dictionary, and we'll say longitude as double. If, however, it fails, we are simply going to return nil, and we can actually make it a returnable nil initializer. Self.latitude equals to latitude, and self.longitude equals to longitude. And now you can actually see that the taking out the values like the latitude and longitude and populated it into a flood structure is become more confined to the structure itself. So now we can go back over here, and instead of using this particular code that we wrote earlier, we can simply create let flood equals to flood, and guess what? Now we have a way to pass in the dictionary. You can see that, and we already have a dictionary, which is flood dictionary. If this succeeds and it doesn't return null, then we can go ahead and process something else further on. So what do we want to do when we actually have that particular dictionary? Well, we obviously want to create an annotation and add it to the map view annotations. So let's go ahead and do that. So I'm going to say over here dispatch queue, because we have to do this in the main thread, async, and some code over here will go. So we're going to create a flood annotation, and you can name it anything you like. MK point annotation. So that's the same exact code that we wrote basically earlier. And then we can say flood annotation, which is this one, dot coordinate equals to CL location coordinate to D, and passing in the latitude and longitude. Guess what? We already have the latitude and longitude. It's in our flood object, flood.latitude and flood.longitude. So we pass that in, and finally we add it to the map view. So map view.add annotation, which is this one, and then we add the flood annotation. Let's go ahead and build this so that we can make sure that everything is working fine. All right. Now let's go ahead and run our application. All right. So if this is all successful, we should be able to see a couple of annotations being added. Let's go ahead and run it. We may have to change that. Right now the person is actually driving, so we may have to change that. But here we go. You can still see that few annotations were added. We have to go and tell it that don't drive. So let's go to the location and maybe do Apple. Not sure where those annotations were actually headed. They might have been added to the Apple campus. But since the person is actually driving, we can't really see those annotations right now. All right. So if we move, hopefully, somewhere those were added. But that's okay. I can simply add another annotation over here, and you can see that it added an annotation, and it is using the flood one, which we also have to fix. So I'll go ahead and fix that also. Not sure why it actually added flood one. Let's go back over here. Okay, so this one has to be like the child ID, which we mentioned earlier. So child by auto ID. That should be good enough. All right. And let's go ahead and run it again. we should be able to see that particular annotations that we added. And you can see that, here we go, we can actually see a couple of different annotations being added on our place. All right, so there's like one annotation right now. I think the other annotations are maybe somewhere else. That's why we can't really see those right now. Okay. So in the next lectures, I'm going to show you that how you can run it on the multiple devices, and when one person adds the annotation, the other one will also see it real time. We're also going to kind of like limit the zooming in part, because right now you can see it zooming in. So even though if I move if I go somewhere else, it kind of like zooms in and sticks to that position. So we would like to stop that from happening. All right, so in the last lecture, you saw that how we were able to retrieve the flooded region, the flooded records from the Firebase database, and we were able to display those records onto the map view control. Now, in this small lecture, I want to show you how would it look like if multiple people are using your app. So what I have done is I have installed the app on obviously our simulator. This is the actual device. This is my actual physical iPad being reflected over here using the reflector app. So we're going to see that how it actually behaves when you have multiple users using different devices. I'm using simulator over here, and this is my actual physical iPad being projected over here using reflector app. So how would it look like when you do that? So first of all, let me go ahead and run the application on the iPhone 8 plus the simulator. So here's the actual simulator trying to run now. This is a very, very performance and memory intensive operation we're trying to do, and you may be able to hear the MacBook actually churning right now. I've also removed all the records from the database so you can see fresh what actually happens. Now, if I'm going to launch the High Waters application on my physical iPad, you will see that it has the same, oops, that's a wrong app. Let's go ahead and launch the right one. There we go. This is our app, right? So you can see that the difference is clear. On the left-hand side, I am in San Francisco, but on the right-hand side, I am in somewhere else, Houston, Texas, right? And this is giving the kind of like the more accurate positions. Now, you may also see that I have turned off the zooming. And if you go over here, what I have done is I've simply commented out the code on 122 line because I want to show you what actually happens. And if you're zooming in, you may not be able to see that, right? All right. So let's say a person in California, which is the left-hand side simulator, marks some region as a flooded region. So I'm going to just click this button and look at what actually happened on the right-hand side screen, which is the actual device, that it added that particular item as a region. You can see on the right-hand side. But you can also see it made 2 entries to the database. So that's a bug that we need to fix. Now, if a person in Houston over here, that's me, marks something as flooded, so I'm going to click the button, and you can see that I have added 1 entry over here. And it also has refreshed onto the left-hand side. Cool, right? Now, if I go ahead and delete any of these entries, so if I go, oops, not over here, maybe just delete one of these entries. So let's say if I delete this, and you can see that nothing really happens. They don't really react to deleting, and that's not good. If someone actually deletes, if there was a functionality of deleting these particular flooded regions, then the simulator as well as the actual device should be able to see that what is being deleted, and they should remove it from the screen, from the map view annotations, because now the information that they're portraying is kind of wrong. I mean, these areas are no longer flooded. So we need to fix that, and that is exactly what we're going to do in the next lecture. In the last lecture, you saw that when I was deleting annotations data from the Firebase database, the simulator as well as the iPad, the physical iPad device, they were not really refreshing. I mean, they were really not doing anything at that point. So we need to fix that. We need to remove the annotations when the annotations are deleted from the Firebase database. The easiest way to do that is to kind of start fresh and remove all the annotations and then re-add them again. Meaning, whenever any change occur using the Firebase observation that we are attaching, we can simply say that go ahead and remove the map view annotations. So remove the annotation and passing in the array of all annotations on the map, which you can access using self.mapview.annotations. Now, this is not the best way to do it because every time any change happens anywhere, you are going to remove all the annotations and then add all the annotations back again. And that's okay for now. In the later lectures, I'm going to show you that how you can create the observation which are only based on when something is actually removed or added. But for now, you can use the value part of it. All right. With that in place, let's go ahead and run our application. So I'm going to run it on the iPhone 8 Plus simulator. And I'm going to also make sure that I am actually running the app on the physical iPad, which is over here, right in the middle. And you can see that it calculates and it knows where my user location is. On the simulator, I am somewhere in California, but on my iPad, you can see, I can actually zoom in a little bit. You can see that I am actually in somewhere in Houston, Texas. All right. So let's go ahead and add an annotation, basically marking the area as flooded area in somewhere in California. All right. Let me go ahead and zoom out a little bit, and you can see that even though I am in Houston, I get that immediately being updated. Now, you might be asking, how is it possible that you get like immediately updated without refreshing your view, without pressing a button, without doing a pull down to refresh? The reason is that behind the scene, your app is making a socket connection with the Firebase service or the Firebase database. And a socket connection is kind of like an immediate connection. So if you were sending the request and response, that may end up with a lot of request and response. So you're handling one wired connection from point A to point B. And this is actually how a lot of Internet of Things devices work. Your camera, your home security system, your doorbell, if you have those kind of Internet of Things devices. Let me go ahead and now in Houston, I'm going to mark the area as flooded. So I'm going to just press a button, and you can see that even though I am in California on the left-hand side simulator, I get that particular item. All right. Now let's go ahead and remove one of those items. So I believe this one, the second one, is the one that is in Houston. So I'm going to remove that, and I'm going to delete it. And you can see that it actually got deleted from this side. But the reason it didn't get deleted from this side is this is running the older version. So make sure that you are running the newer version of the application. So let's go ahead and do that. I'm going to run the app over here, and I'm going to make sure that I am running the current version on both. All right. And this is one of the things that you will see that if you are testing it out on multiple devices, you always have to make sure that you are running the current version. All right, so now we have the left-hand side and we have the right-hand side. I'm going to mark something as flooded, as you can see that it adds an annotation. And I'm going to go ahead and remove the one in California, which is the first one. So let's go ahead and remove that. And boom, you can see both of them getting updated at the same time. And now both of them are indicating whether you're running it on a simulator or you're running on an actual iPad. They're both indicating there's only one flooded region, which is in Houston. Let's go ahead and delete that also, and you will see that now it's gone from both. Now I'm going to go ahead and add a flooded region in Houston and a flooded region in California. And now we are back to 2 flooded regions. All right. And there you have it. You have created your first Firebase application that actually saves some very, very important data to the Firebase database. And I hope you have got the grasp of the basics for learning the Firebase database. Now we are going to work on 2 more different kind of apps in this course. Obviously later on I'll add more kind of apps to give you more exposure to the Firebase database, but we are going to learn a lot from these apps. And the great thing about building apps is you are creating something really practical and you are learning at the same time. So I hope you like this particular section on creating the High Waters app and integrating it with the Firebase database. And let's move on to the next section. We're going to create a completely different app. Thank you so much.